Hey guys. Welcome back to my channel. I am Shivam Kumar Bhatnagar. Today I will discuss the integration testing in detail. Let's move to the introduction part. Integration testing is the second level of the software testing process, comes after unit testing. In this testing, units or individual components of the software are tested in a group. The focus of the integration testing level is to expose defects at the time of interaction between integrated components or units. Unit testing uses modules for testing purposes, and these modules are combined and tested in integration testing. The software is developed with a number of software modules that are coded by different coders or programmers. The goal of integration testing is to check the correctness of communication among all the modules. Let's take an example. First, we will log in as a user Amit to amount transfer and send the 600 rupees amount. The confirmation message should be displayed on the screen as amount transfer successfully. Now log out as Amit and log in as user Suresh. Go to the amount balance page and check for a balance in that account equals present balance plus received balance. Therefore, the integration test is successful. Also, we check if the amount of balance has been reduced by 600 rupees in the Amit user account. Click on the transaction. In Amit and Suresh, the message should be displayed regarding the data and time of the amount transfer. Now I am moving to integration testing techniques. Any testing technique, black box, white box, and gray box, can be used for integration testing. Some are listed below. Black box testing, state transition technique, decision table technique, boundary value analysis, all pairs testing, cause and effect graph, equivalence partitioning, error guessing, white box testing, data flow testing, control flow testing, branch coverage testing, decision coverage testing. Types of integration testing. Integration testing can be classified into two parts: incremental integration testing, non-incremental integration testing. Incremental approach. In the incremental approach, modules are added in ascending order one by one or according to need. The selected modules must be logically related. Generally, two or more than two modules are added and tested to determine the correctness of functions. The process continues until the successful testing of all the modules. In this type of testing, there is a strong relationship between the dependent modules. Suppose we take two or more modules and verify that the data flow between them is working fine. If it is, then add more modules and test again. For example, suppose we have a Flipkart application. We will perform incremental integration testing, and the flow of the application would be like this: Flipkart right pointing arrow login right pointing arrow home right pointing arrow search right pointing arrow add cart right pointing arrow payment right pointing arrow logout. Incremental integration testing is carried out by further methods: top-down approach, bottom-up approach, non-incremental integration testing. We will go for this method when the data flow is very complex and when it is difficult to find who is a parent and who is a child. In such a case, we will create the data in any module, bang on all other existing modules and check if the data is present. Hence, it is also known as the Big Bang method. Integration testing follows unit testing and precedes system testing. While unit testing focuses on testing individual units of code in isolation, integration testing takes a broader perspective by examining how these units collaborate and interact within the entire system. Key aspects of integration testing include: testing interactions. Integration testing verifies that different modules or components interact correctly with each other. This includes checking data flows, communication protocols, and the overall integration points. Types of integrations. There are different levels of integration testing, including Big Bang integration. All components are integrated at once, and the entire system is tested together. Top-down integration. Testing starts from the top module, user interface, and progressively integrates lower-level modules. Bottom-up integration. Testing begins with the lower-level modules and gradually moves to higher-level modules. Incremental integration. Components are grouped into subsets. Each subset is incrementally integrated and tested. Stubs and drivers. During integration testing, certain components might not be ready for testing due to dependencies. Stubs, for lower-level components, and drivers, for higher-level components, are used to simulate the behavior of missing components, allowing testing to proceed. Data flow and control flow. Integration testing evaluates the flow of data and control between different components. This includes checking if data is passed correctly, control is transferred appropriately, and errors are handled properly. Functional and non-functional testing. Integration testing addresses both functional requirements, correctness of interactions, and non-functional requirements, performance, security, etc., that arise when components are integrated. Interface testing. Interface testing ensures that the APIs, protocols, and communication mechanisms between components work as expected. Regression testing. As new components are integrated or existing components are modified, regression testing is performed to ensure that existing functionality is not compromised. Issues identification. Integration testing helps identify issues such as data inconsistencies, communication problems, and compatibility issues that may not be evident during unit testing. Concurrency and parallelism. In systems with concurrent or parallel processing, integration testing examines how components handle shared resources and synchronization. Black box and white box approaches. Integration testing can involve both black box testing, focusing on inputs and outputs, and white box testing, examining internal logic and code. System integration. Once integration testing is successful, the system is ready for more comprehensive system testing, where the entire software is tested as a complete entity. Integration testing is critical because even though individual units might pass unit tests, they can still exhibit unexpected behavior when combined with other units. Detecting and resolving integration issues early in the development cycle helps ensure the stability and reliability of the final software product. Please subscribe to my channel and click on the notification bell icon. Thanks for watching.